VTEC system. VTEC stands for Valve Timing Electronic Control. This one, typically we're not changing the position of the cam relative to the belt or the chain. So we're going about things a different way. So what we're looking at here is two valves. So this could be two intake or two exhaust, either way. And for those two valves, we would typically have two lobes, right? So each valve would have its own lobe, its own little rocker arm or cam follower, and it would be controlled. It's hard to see in this picture, but on the Honda VTEC system, between those two normal lobes, they put a third lobe in the center. And the third lobe is normally a little bit taller, so more valve lift, and it's also a little bit wider, meaning more valve duration. So we're going to push that valve further open and keep it open longer. Would that help with performance? So on that third lobe, it has its own little rocker arm, but there's no valve there. So that rocker arm is just kind of along for the ride normally. When we want VTEC to kick in, there's pins that can connect all those rocker arms. So when VTEC engages, all three rocker arms get connected together, and basically we're operating both of those valves off of that third lobe in the middle. So now we're operating both those valves with higher lift and higher duration. So we get more flow past them, we can make more power. And it's usually engaged based on RPM. So higher RPM will do that to where we can make more power. As the RPM drops, we disengage it, we operate off of our normal cam lobes, which we design more for better fuel economy and better emissions. So instead of having sort of infinite adjustment, we basically have two cams built into our engine. So we got one cam we're using for low speed operation, another cam we're using for higher speed operation. And that's also oil pressure controlled with a solenoid. So here's a little bit better picture of that. So we've got our two main lobes. We've got that center lobe that's going to be a little bit higher lift and duration. Here's our three rocker arms. And in between those rocker arms is these locking pins. So when we lock all three rocker arms together, we force the center lobe, the bigger lobe, to operate our valves. So again, we're getting to a situation now where we've got one lobe, at least sometimes, operating two valves. So would that lobe be subject to a little bit more wear and tear potentially? Especially if we're not changing our oil often and things like that? Yeah. All right, one other quick related thing, this is what we call a cylinder deactivation system. And different manufacturers have a bunch of different names for this. But this is technology that's becoming more common. This is where we can have an engine and not run it on all the cylinders all the time. So say for example we have a V8 engine, we're going on the freeway and we don't get a lot of power, we can run it on just 4 cylinders. Or maybe just 6 cylinders. So that would give us better fuel economy, right? The way that we're typically doing that is with some special lifters. So we have hydraulic lifters, and basically when we want to shut off certain cylinders, we change the oil flow to this lifter, and what it'll do is it'll keep valves on certain cylinders completely closed. So we keep those valves closed to where that cylinder is not bringing in any fresh air, it's not pushing out any exhaust gases, and we just have basically a cushion of air inside the cylinder that expands and contracts. So now we're only making power on certain cylinders. And this is also something that can be activated and deactivated very quickly on the fly. So when we want power, all 8 cylinders engage. As our power needs drop, we can drop down to 6 cylinders or only 4 cylinders. So a lot of the Chrysler engines have done this. A lot of the Chrysler Hemis do this. Chevy's done this on some of their engines. There's some other manufacturers that mess with this as well. So this has become sort of a more popular system. And again, there's some different variations depending on exactly what our valve train looks like, but they're all going to do kind of the same basic idea. So just disabling some of the valves.